Alright guys, I just started learning assembler using Nasm and Freepascal. I found that I couldn't really find a lot of information with Nasm and Freepascal. So this little bit of information I've put together hopefully will help somebody, hopefully more good than harm, but if I make any mistakes, just mention it in the comments. So let's start. I got 3 files here, and this is the main program that tests the functions. My unit here with the 3 functions, and my assembler code with the 3 functions that I'm linking in here using this directive right here. Anyway, I'm gonna comment out the other 2 functions here just to keep it simple, and I'll go through each function. First though, I'm going to compile everything just to show you how I compile things. I have a Windows command prompt, and I also have a DOSBox command prompt. The code that I compile through here is going to be through a cross compiler or the Windows Nasm compiler, and the Freepascal cross compiler. And I can't run them in my Windows command line. I can only run them in the DOS box here, so that's why the 2 windows. So let's start off with compiling the assembler code. So to create DOS or 16-bit object code, you need to use the NASM-F OBJ format. myfunc.asm is my source file, -o is my output, and myfunc.obj is my output file name. So if we compile this, we didn't get any errors, so that means it created the file. So let's just take a look at the object file just to see. So here it is right here, 11:05. That's the current time. So it did create that. All right. Next, let's compile the unit, and we're going to be using the Freepascal cross compiler. So this is a little tricky to remember all the time, but it's a PP cross 8086, and myfunc.pass is the name of the unit. Enter, and it compiles the unit. And now let's compile the main program. So I'm using the large model here. So you have to use -WM large. And I'm using this because this is at least compatible with Turbo Pascal. So whatever I do here, I could use the Turbo Pascal compiler also, and it works the same way. So let's compile this, and it's worked. So let's just run our sample program, and it doesn't work because it's a DOS program, and it tells you here you can't run that. So if we come here now, test func, and so we get pass in, that's the name of our function, n2 equals 20. All right, so let's look at the code now. So we actually passed a value of 10, and we're printing this value here, n2. n2 equals n2. So what's happening here? Let's take a look at our unit. And what does our say here? It says that our first input is just a regular integer, but our second parameter is a var n2. That means we actually have to put a variable in the second location. And what it's doing is taking the first value and incrementing it by 10. So let's see what's happening in the assembler code. So in the assembler code, we have it declared here. And if we take a look here, that's where it starts off at. A bunch of assembler things happen here. This happens in every function you create. I'm not quite sure of this local stack space, but that's what the sample programs or the sample listings have. And this is the meat of the function basically. So the first perimeter, the first value is located right here. You have to specify it this way in the square brackets, and we're moving it into the accumulator, the AX register. And then we're adding 10 to it. And then we're taking the second value and putting into the SI register, and then we're taking the value from the accumulator, the AX value, and passing it back to the SI address because it's in square brackets, and so that changes the value of N2. Remember, N2 is a variable, so if we go back here, var N2. So by doing this function right here, we're returning the variable information. So this is one of the things that took me a little while to get a grasp on. So hopefully I've helped somebody here. And so that's why this function works that way. We were able to see that if we pass 10, we got 20, and that's how it works. So let's move on to the next function. So I'm going to comment the first one out. So the second one is similar, but we're using two variables. So let's save this, and I will recompile again, and let's just see what the result is. I'm not going to compile the assembler code because that hasn't changed. So if we jump to our DOS box again and run this, we see now that we have N1 equals 20, N2 equals 30. So let's take a look at our input values. Our input values are 10 and 20. So it added 10 to the first value and it added 10 to the second value, and that's what it printed out. So let's see how we do that. It's very similar to what we did before, except this time we're modifying both variables. So in the first one here, we were only modifying N2. See this right here? We were only modifying this. Now with the second function, we are modifying both variables. So whatever result we're getting by adding 10, we're passing back the value to both variables. So we have the first one here and the second one here, and we're doing the same thing. If we wanted to change the value here, we probably get a different result, but I did that with the first one, so I don't think I'll be doing that. So that's how that works when you have both are var, basically. You can change the values that way. But you might not want to do that, so that's why I have the third function. So let's jump to the main code again, and I will comment out the first two functions. And if we look at this one, we have one input value and one return value. So let me compile this one again. And let me just make sure I save it. And let me compile that. And back to our DOS box. And let's run this now. And so it says return result equals 40. So let's take a look at what our input value was. So our input value was 30. Notice it's not a variable. It's just a straight value. So if we look at our function here, it's a function, so it takes a return value. And our input value here is just integer. It's not a var, so that means you could put a regular number or a variable if you like to. When it's a var, you have to put a variable of the same type. But when it's just a straight integer or word, you could just put the actual number. You don't have to worry about variables. So let's jump to the last portion. So this is our last function, and it's the simplest. And because the compiler is actually doing doing some things automatically, so we don't have to do as much here. So again, just like the other functions, the first value, we're taking it and putting it into the SI register, and taking the SI value and putting it into the accumulator, the AX, and then we're adding 10 to it. And it seems like we're missing something because we're just adding 10. But by default, at least in Nasm, the AX value is returned as the value of the function. So automatically anything in AX, if you're calling a function, just like we are, it's a function, anything that's in AX will get assigned to this function. So that's how that's working. Um, Now, the only thing I don't understand is normally when you're assigning values from the SI register, normally it's in square brackets. Now, if I put square brackets around this, it fails. And that's one of the things I don't understand. I've even put it here in the comment section. So if I do this, it will fail. So let's just try it. I will compile the assembler code, the unit, and the test. And so if we go back to our DOS box now and run the same function, see how we're getting a bad value here. 267 is not what we are expecting. So obviously it doesn't work with the square bracket, and I'm not quite sure why. So you might run into that. I haven't figured it out, but if you do find out, let me know. So this is as much as I've learned at this point. Um, let me jump to our DOS window here, and let me just show you it also works with Turbo Pascal. So I have the Turbo Pascal command line compiler. I'm using 7.1. I don't have to compile the assembler. Let me actually just do the assembler code just in case. There we go. So now if I build it with Turbo Pascal, just use the /B and then build it. Look how much smaller the exe is right now. So much smaller, and that's because again Turbo Pascal has less features and a smaller runtime than Freepascal. So that's why the exe is smaller. All right, so let's run it and see if we get the same result, at least for the last function. And we get 40 as well, so it works the same way. So let me do one more test. Remember how I mentioned before that if you use the wrong model, that it will fail. So let's compile with medium. So let's just take a look at what happens now. Oh, I actually worked with medium. Okay, let's try small. There we go. So we just crashed it. So this is how in assembler, if you mess up, you mess up hard. So it's frozen, it's stuck, we can't get out of it. Anyway, so I'm going to end the video here. Hopefully you've learned something. The code will be on my GitHub, link in the description. Thanks for watching.